Stop exposing port 3389 to the internet right now. I just reviewed a client's Azure environment where they had 47 VMs with public IPs and open RDP ports, and their security logs showed over 200,000 brute force attempts in a single week.
That's terrifying. But wait, how else are we supposed to remotely manage our Windows and Linux VMs in Azure?
Hey everyone, welcome back to the Network Ninja Cloudcast. I'm your host, and today we're diving into Azure Bastion, the service that completely eliminates the need for public IPs on your VMs.
Hey everyone, I've been dealing with this exact problem, so I'm really excited to learn the right way to do this.
Perfect timing then. Let's fix this security nightmare once and for all.
So what's the actual problem with the traditional approach? I mean, I've always just assigned a public IP to my VM and connected via RDP on port 3389 or SSH on port 22.
That's exactly what most people do, and it's a massive attack surface. When you expose those ports publicly, you're essentially putting a door on the internet and hoping nobody guesses the key. Those 200,000 brute force attempts I mentioned? That's not unusual. Attackers run automated scanners 24/7 looking for open RDP and SSH ports.
Okay, so Azure Bastion is the solution. But I'm confused about what it actually is. Is it like a jump box or a VPN?
Great question, and this is where the architecture gets interesting. Azure Bastion is a fully managed Bastion host service that you provision inside your virtual network. Think of it like a security checkpoint at an airport. Instead of passengers walking directly onto the tarmac to board planes, everyone goes through a controlled checkpoint first. The planes, your VMs, never need to be directly accessible from the outside world.
So the checkpoint handles all the security screening, and the planes stay protected behind it?
Exactly. And here's where the analogy holds up technically. Azure Bastion sits in a dedicated subnet called Azure Bastion Subnet, and this name is mandatory. You can't change it. It must be at least a /26 CIDR block, so that's 64 IP addresses minimum. The Bastion service terminates your RDP or SSH session over HTTPS on port 443, then creates a separate, private connection to your VM using the VM's private IP address.
Wait, so my browser connects to Bastion over HTTPS, and then Bastion connects to my VM over the private network? The VM never sees my public IP?
Precisely. And I should mention that while the Azure portal gives you a browser-based HTML5 experience, if you're using the standard SKU or higher, you can also connect through native clients like mstsc.exe or OpenSSH using Azure CLI commands like asnetwork bastion RDP or asnetwork bastion SSH. But either way, your VM only needs a private IP address. No public IP, no exposed ports, no network security group rules allowing inbound RDP or SSH from the internet.
Oh, interesting. So there are different SKUs? What's the difference?
Good catch. Azure Bastion comes in Developer, Basic, Standard, and Premium SKUs. The Developer tier is for dev/test scenarios and only supports a single VM. Basic gives you the core browser-based connectivity. Standard and Premium unlock features like native client support, IP-based connections, shareable links, and Kerberos authentication. For most production environments, I recommend at least Standard SKU for that native client flexibility.
Got it. But you mentioned just-in-time access in the title. How does that fit in?
This is where we layer in Microsoft Defender for Cloud, specifically the just-in-time VM access feature that's part of Microsoft Defender for servers. Even with Bastion, you might want additional controls. JIT access keeps those ports closed at the NSG level until someone requests access. When approved, it opens the port only from specified source IPs, only for a specified duration, which can be anywhere from 1 to 24 hours, and then automatically closes it again.
So it's like the security checkpoint only opens during your scheduled flight time, and then it locks down again?
Perfect extension of the analogy. And here's the technical implementation. JIT modifies your network security group rules dynamically. It adds a temporary allow rule with a specific source, which by default is the requesting user's IP address, a specific destination, your VM's private IP, and a time-based expiration. Once the window closes, the rule is automatically removed.
Wait, so JIT and Bastion are separate things? Can they work together?
Great clarification to make. Yes, they're complementary but independent features. JIT works with or without Bastion. When you use them together, you'd configure JIT to allow traffic from the Bastion subnet or use the Azure Bastion service tag as the source, but that requires explicit configuration. It's not automatic. The combination gives you defense in depth, Bastion eliminates public IP exposure, and JIT adds time-based access control.
What about the network security boundary? I've heard that term, but I'm not totally clear on what it means here.
The security boundary is essentially the perimeter you're defending. With traditional public IP access, your boundary is the VM itself, which is a weak position. With Bastion, your boundary moves outward to the Bastion service, which is hardened, managed by Microsoft, and only accepts connections over TLS 1.2 or higher, including TLS 1.3, on port 443. Your VMs sit in a protected zone that has no direct internet exposure.
So we've essentially moved the castle walls further out and added a moat?
I like that analogy. The Bastion subnet is your fortified gatehouse, and your VM subnets are the inner keep. Traffic must pass through the gatehouse, there's no secret tunnel around it.
What are the common mistakes people make when setting this up?
The biggest one is subnet sizing. People create a /27 subnet with 32 addresses, and then Bastion deployment fails because it requires /26 or larger. The second mistake is forgetting that Bastion needs its own public IP. You need to provision a standard SKU static public IP address and associate it with the Bastion host. You manage this IP resource yourself, but Bastion controls what traffic it accepts, which is only HTTPS, not direct RDP or SSH. The third mistake is leaving old NSG rules in place that still allow 3389 or 22 from the internet. Bastion doesn't help if you've left the back door open.
Let me make sure I've got this. Azure Bastion is a managed Bastion host service that sits in a dedicated /26 subnet, accepts HTTPS connections through the Azure portal or native clients depending on your SKU, and then privately connects to my VMs over RDP or SSH, without those VMs needing public IPs or internet-exposed ports.
Spot on. And when you combine it with just-in-time access from Microsoft Defender for servers, you get time-limited, audited access that automatically expires. Just remember to explicitly configure JIT to use Bastion as the source if you want them working together. Your 3 takeaways are: first, deploy Bastion in a properly sized Azure Bastion subnet of /26 or larger, and choose the right SKU for your needs. Second, remove all public IPs and internet-facing RDP/SSH rules from your VMs. Third, enable JIT access for an additional layer of time-based control, configured to work with your Bastion deployment.
This is going to save me so much worry about those brute force attacks.
That's it for today's episode. If you found this helpful, please hit that like button and subscribe to the channel.
And share this with anyone who's still exposing RDP to the internet.
Thanks for watching the Network Ninja Cloudcast. See you in the next one.